to note that these new gen topics, I wouldn't even say new gen because AI is here to stay, has got a record registration of more than 150 people. So it indicates how much of importance we place on this as chartered accountants and how we all want to acquire knowledge on this, and we are accepting that it is here to stay, and it is going to be a part of our accounting and auditing life. And even though it has been a nice rainy morning, I should say nice because we need the rains, the storms have not kept everyone away. Everyone is coming, and many people have already come. Some people are there having breakfast. So we will start this program without much ado. I'll just give a brief introduction about CA Jayendran. He's a chartered accountant and a data scientist from IIMB. And he is the co-founder and CEO of Vyakya Technologies, and he has created an AI platform for finance and accounting called as Prudent AI. Previously, he was the analytics director at EY, and he has 15 plus years of experience in the intersection of accounting and technology domains. And he's worked with leading global organizations and created multiple tech solutions in the accounting domain. And he is generously offered to share his knowledge and experience with us. Before he takes over the podium, I just wanted to give you a brief about the next two important programs. One, on November 30th, we are having a breakfast meeting on professional opportunities for young chartered accountants, which will be led by our Central Council member CA G. Shekhar. And on December 11, we are having a one-day hands-on workshop using Python on data science applications in accounting. This will be restricted to 25 participants on a first-come, first-served basis, and everyone should bring their own laptop. So there are a lot of other programs, I think, which we can check in our SARC website and the journal. So over to CAJ.
Good morning, everyone, and thank you for coming in despite the weather today. I look forward to the next couple of hours of the session, speaking and interacting with you. I'm hoping this will be not a one-way traffic in this session. Please feel free to interrupt. Please feel free to ask your questions as and when you need to. And we will also have some time in the end for some questions. I'll begin straight away. So, like I said, to set context, it is not the future. It is the present. It's already all around us. If you can see, AI is already an active part of a lot of products and solutions we use. That's Amazon, it's Facebook, or Gmail. So we are already well and truly AI consumers today. So this, with that context, I wanted to talk about how this makes sense for us as accountants as well. So, I had some videos I wanted to play, but I think we have some trouble with the audio, so I'm just going to skip right ahead. But the context is just about how it is already very, very important part of our regular lives today. So just quickly about me, chartered accountant and IIMB, and I've spent some time working in a lot of the businesses you will probably recognize in Chennai. I've been around in accounting firms, in accounting roles, as well as in some technology roles over here. And some experiences which are probably relevant have been an auditor, worked with a lot of CPA firms in the US, selling accounting outsourcing and tax outsourcing solutions, worked in EY and built some tax technology, accounting technology solutions at EY as well. So, and I continue to do that today in my own startup. So there is some practical relevance to what we're going to speak today versus what I do. So just very quickly, Prudent AI is the platform that we've been building. It's an accounting and finance platform on which we build multiple solutions. As a startup, we have a solution for audit. We have a solution in which we do MIS and management reporting, and we have a solution in which we have a scan bot in which we scan and recognize solutions from documents, for example, from invoices for accounting, for TDS, and different purposes. We build multiple solutions on top of it. I'll talk about it in more detail in general. And as a startup, we're part of a couple of leading accelerators, NASSCOM's 10,000 startups, and also Accelor are two accelerators we've been recognized by and a part of. So just quick setting context about our accounting fraternity, where we are today. Please feel free to agree, disagree. This is my view. So typically where distribution of where people are working today, accounting firms, I would imagine there are a lot of people in finance departments. These are the leading employers of CA today. Anybody else from any other than what we're listing here? We've listed shared services centers, IT companies, financial services, and investment banks, and maybe IT consultants. What is the distribution? How many people are practicing chartered accountants in the room today? Okay, so majority is practicing chartered accountants, and the rest, I'm assuming, are in the industry. Anybody in the IT technology side? Okay, fantastic one. Right, thank you. So this is a typical profile and professional profile. Why is this important? I'll come to it. Basically, just 4 attributes. One, I think as a profession, it's a profession that is very similar to 2 other professions, lawyers and doctors. In
Are you going to cover bots application in ITR filing, PST filing, ROC filing?
I'm sorry, I couldn't hear you.
No, are you going to cover the bots application in ITR filing, MCA filing? That in the topic or?
No, MCA filing, no, not specifically. But we will talk about different use cases. There are similar use cases, but MCA and ITR filing specifically, no. So yeah, so there are a couple of industries professions which are very similar. Lawyers and doctors and healthcare professionals both have the same kind of a qualification rigor. There's a very complex knowledge and skill base. There's a lot of vocational training. People come to the profession already with a lot of hands-on experience. Why is the similarity important? Because the similarity is also important in terms of how AI is applied in these professions. There is a lot of similarity in how accounting AI works in the same way as AI works in healthcare, how it works in the legal fraternity as well. And broadly similar distributions, lot of supply of labor meaning interns, graduates, because there is a vocational aspect. There's a lot of supply of talent, but at the same time it tends to be a little bit of a behind the scenes kind of function in most organizations, not necessarily the front and center, and different domains of operation also. And one of the things that is very interesting is also the fact that there is a lot of demand for consistency in terms of output from these industries. So I just wanted to also quickly profile the room in terms of technology exposure, what level of technology different people are exposed to. So I'm categorizing it in 4 levels. So tech operators who are pretty much everybody, because we all use an accounting software or an ERP. We all use Excel. I don't think a chartered accountant can function today without these two. So this pretty much all chartered accountants are tech operators, pretty much right from the word go. And I just wanted to also understand, so which categories do people fall in, meaning people who do advanced Excel, macros at least, and who've seen ERP implementation, been part of an implementation project, or work with dashboards, software like Tableau or Power BI. How many of you? Quick show of hands, please. 2, 3. Okay, a few. Fantastic. So there is the tech implementers, which is typically people who are actually working in their functional consultants or tech consultants implementing these solutions. And the fourth category is people who are doing advanced technologies, who are within the domain also doing data science work, or who are doing programming type of work. So these are 4 categories of skills. I just wanted to understand. Typically, I feel, from what I've seen, 90% of the chartered accountants fall in the tech operator category. There is a substantial portion divided between the operator plus and the implementer group. Very few in the advanced technologist category. And this is also relevant in terms of how this business develops and adopts. And typically what drives these professionals, please feel free to agree or disagree, but typically what drives, one, of course, like pretty much all professions, financial prosperity is important. Impact is very important. Typically the respect the profession gathers is important. These are drivers that typically any chartered accountant looks for. And this is different in different professions. Normally the legal and medical professions also carry very similar attributes. And I'm just using it to set some context, because the application of any technology or AI in every industry is different. The industry profiles drive how the industry adopts it. So I just wanted to make sure we have something about our profession first. But yeah, we'll get into the meat of what we are doing. So which is, what is AI? Just to get some context, there is a very simple data science maturity model. This is very common. There are a few variants of it, but basically it moves from being able to do reporting to analysis to monitoring, forecasting, predictive, prescriptive, in that order, and goes up in both in terms of complexity as well as in terms of business value. How much business value and how much complexity each of these come up with. We are right now, when we are talking about AI, we are talking on the uppermost corner at this point. And these are all different flavors and different levels of data analytics people go through. Typically you need to go through this maturity model to reach when you are already working with AI. At least as a practitioner, that is the route you need to follow. So to help us understand just further, just 3 important definitions that we will keep using. These are terms we will use in the next hour and a half, so I'm just going to list it out here. Machine learning, basically just a broad field where we try to make intelligent machines or smart machines, where machines understand and make some level of decisions. And AI, when we talk about AI is a sub-branch of machine learning, where we are talking about very specific high-level intelligence. Within machine learning, AI is a sub-segment of machine learning. Deep learning, again, is a AI technique which mimics how the human brain operates to be able to learn and train machines. So when we say machine learning, in a lot of times it is very loosely used. AI and machine learning are used interchangeably, and they are used in different situations and different ways. For an accounting profession, I don't think we need to worry so much about the nuances in the definitions between these two. All machine learning and AI falls under the same broad category as far as a user and application is concerned. So what has changed? So why is AI such a big deal? What has changed? The traditionally, so classical programming or software or all technology that we have been using so far before pre-AI has always been on this basis. There are rules and there is data, and together your software runs on it and gives you answers. And AI basically is the other way around. There are data, there is answers, and the machine interprets the rules. So AI is a system in which you already know the answers, and then you're training to learn the rules to make further answers. This is the practical difference between these two approaches. So when we are typically talking about software implementations, when we are talking about technologies like RPA, we are talking in the first category, which is in the we will tell you the rules, you codify it. When we are talking machine learning and AI, we are not talking about we will tell you the rules, we are talking about we will teach the machine the rules. So there is a huge difference in how these two things work and some tasks that they typically perform. These are all very common jargon terms that you will keep coming across when you're talking about AI or reading articles in it. So regression is essentially how much will it rain today or how much will it rain this monsoon. Typical answer that you expect is a mathematical output or a number. Classification is the most common use. That is what any AI output or any poll will typically tell you who will win, or it will give you like a will it rain today, yes or no kind of answer. Not mathematical answers, but categorical answers. And clustering, of course, is the third use case where you're grouping and saying these are all chartered accountants, these are all company secretaries, these are all chartered accountants in the metropolitan city. So they are like a special category. So you cluster and segregate a large group into smaller clusters to be able to address them. Extremely commonly used in marketing, extremely commonly used in most situations where you're involving large groups of people. So these are three typical AI outputs or use cases on top of which all other problems are solved. So if you look at it from our industry perspective, regression is typically what you will use for forecasts. If you want to know what is going to be like the revenue forecast, or what is going to be like amount of defaults on like a financial services on a loan portfolio, you will use regression. Classification is typically what you will use for risk scoring of transactions. We use it a lot in audit to say whether a transaction is risky or not risky, to say whether a transaction would, to say whether a transaction is fraudulent or not fraudulent, or a buyer is likely to default or not default on payment. That's classification. Clustering is, of course, grouping transactions in different categories and risk levels based on transactional attributes, and again very popularly used in fraud detection and analysis. It is very practically used by the income tax department to identify and target assessees for verification, targeting assessees or targeting specific groups of tax returns for deeper focus. Clustering is the technique that they typically use. And in that context, this is just some three like we talked about three outputs, we need to talk about three functions that AI allows computers to do. How do they allow computers to see or vision? This is basically what is used in all our technology that we use for OCR. So for example, when we build a solution, we built a solution out where we review tax TDS accuracy on payments, on vendor invoices. So we need to build a function in which it can read a scan of an invoice, identify what is the nature of service, identify what is the tax impact on it, whether TDS is applicable, and how much at what rate should it be deducted. So this is the function. So this is typically how, that's like a handwritten digit, which is then broken into a grid, and then it is read by the computer in this fashion. And it essentially says within the grid which squares have ink, which squares don't have ink, to identify and then represent an output. It will basically say within 0 to 9, what is the probability of this being all these digits. It will give you a probability output for all of these, and the highest will typically be the answer. So it will give you probabilities like 0.1 to, and then you realize that 70% likelihood that it is a 2, and that's how you identify. So this is typically what happens in the back end. When a computer is processing and giving you output, it is giving you probabilistic output, it's not giving you definitive output. Natural language processing, of course, this is again something that we practically use all the time. Google Translate is an example of how it uses. This is what we use for reading language. This is what we use for interpreting documents. For example, when we look at like an asset register and look at it and say what is the nature of this asset based on the asset description, identify what depreciation category it needs to go to, or is there a case law that is relevant to this. This is what we are using. So we use natural language processing. This is very, very commonly used in most systems. Typically, data quality type work happens with this. When you're doing KYC in leading banking systems, when you're doing KYC for customers, and you need to overcome problems like names are misspelled or names are spelled differently, this is what is used. And reinforcement learning, this is actually what you mostly read in the press when you talk about AI, about computers, self-driving cars, computers playing chess, computers playing AlphaGo. This is essentially the end. It's actually more a process than a specific technique, where the computer basically has multiple repetitions of the same test or the same project, and it has rewards on one side, which is typically the fire, and the water is the reward and fire is the punishment. So between reward, punishment and multiple iterations, the computer basically learns to optimize for reward, and then it is now able to do this on future transactions. Typically this is how a computer is able to identify whether the car should go straight, turn left, turn right, or you make what kind of a chess move you should make. So this is reinforcement learning. This is usually what we constantly get referred to and spoken about when we're talking about AI. And there are different use cases for AI, and I wanted to show you one of these. I think it will be a fairly interesting video even without the audio. But this is basically Volvo doing recruitment. I'm going to have to give you a little bit of commentary, but basically Volvo designed a car which selects its own car engineers. Yeah, it's probably better with some caption, but essentially the car is able to interact with the engineer, ask him questions, ask him to show parts or answer based on inputs in the touch screen or output based on voice, and interpret it, and eventually identify and score the individual on different attributes and select. So this is a real use case that's already been tried out in Europe. And because we are here because we are talking about a lot of these AI, data science and analytics, I just wanted to be very clear in terms of helping people segment out these three different fields, and so that there's no overlap. So between analytics versus RPA versus AI, and there is a clear difference. So whenever people are talking about analytics, we are in the zone where we are doing Excel, we're doing PowerPoint, we're doing Power BI, typically what if analysis. So the questions that you can answer are like trends, what happened, what is the forecast for the future. These are typically the questions that you can answer. This is not AI. This falls under the broad data analytics category, but this is not AI. This is analytics. RPA again tends to, a lot of RPA material and RPA vendors tend to say RPA is like AI. RPA is not like AI. RPA is front-end automation, where you are basically automating a task by recording it and repeating it. You are not learning or building anything iterative. You are building and recording transactions and then building rules to execute the recording. It is essentially like a replay or a play in a loop of a transaction. And they are still doing some experimental work to do something more cognitive, something more interpretative with the data and all that, but very early stage. Today, all use cases of RPA are essentially just recording what has been done on the screen and then repeating it. And when we're talking about AI, we are talking about models that have learned from multiple transactions, typically millions of transactions before they are deployed. So which means that if you give the model a document, it will automatically be able to identify and read data. For example, for us, when we are scanning AP transactions, we will be able to look at a vendor invoice and immediately identify wherever, depending on whatever format the data is in, we will be able to identify where the GSTIN is, where the CIN for that customer is, where the HSN for the service is, and based on that, we will be able to also identify the nature of the service, whether it is a service or a product, and if it is a service, what tax category it falls in. So now this is in the AI zone of things, where you already have pre-trained the model with multiple millions of invoices, and then now you are able to now use that knowledge to make a decision today. And the other thing is, there are two other things that typically come with AI. One, the systems typically learn continuously. So it's not a point in time. It does something today, doesn't necessarily mean it will continue to only do the same thing today. Tomorrow it will improve, unlike the other two categories. And it is entirely probability driven. All outputs have a margin for error, all outputs have a probability. It never gives you a definitive yes or no answer. It gives you a probability based on which you then take a yes or no interpretation. So why is this so important now? So what happened now that this has become so important that it was not so important 5 years ago? Why now? So three things, three simultaneous changes have taken place. So the first is algorithms. The algorithms have become extremely powerful. These have been available for a while now. The algorithm availability has been around for a while. This explosion of data is very recent. So we've been able to create 90% of the data that exists in the world, recorded data, has been created in the last 5 years. So from the history of mankind to the last 5 years ago, we've been able to create 10% data, we've been able to create 90% in the next 5 years. So that explosion of data allows a lot of interpretation of that data. And the third is exponential increase in storage and computing power. Computing has become cheaper than ever, storage has been cheaper than ever, networking is cheaper than ever in the world. And we are able to practically see the impact of this every day. For example, from my own experience, when I used to work at EY 3-4 years ago, we needed to go set up a data analytics lab and a server and buy software. This whole process took us close to 6 months for all the approvals and budgets, and people needed to sign off because it was expensive, and we set a budget of about 75 lakhs. It took us 6 months to get it to deploy and work for the first day with multiple vendors and all that. So the same server today in my team, an engineer directly gets to use it at the click of a button. If he decides he wants a server of that capacity, it is available to him on Amazon Web Services or Microsoft Azure on the cloud. It's available to him typically in 5 minutes. From what we spend 75 lakhs for, we spend about 750 rupees for the same server. He uses it for 1 hour, finishes his process, shuts it down. We pay by the minute, and we pay and use it real time. And I don't need to approve it. I don't need to get 3 quotations. I don't need to look at it. It's charged to my credit card in the month end. So this change in computing power availability has made all this possible. So, and this is because this is available like this worldwide, and because there is so much data available, now learning and teaching systems are possible. This was not possible earlier because it was either too economically unviable to do, or there was not enough data, but now both are available. And the algorithms have also been getting better, and now they all have enough data and practical application capacity to be able to test it. So this is why AI is so important and relevant today, and why is it so important for us as human beings? Because we have one unique characteristic, which is we know much more than we can tell. To give you a very simplistic example, if I need to ask for someone to volunteer and tell me in a few steps, like how to make a cup of tea, what are all the steps you will need to do? It's a very simple recipe and a series of steps. In this case, what you know can be completely codified, and somebody else can follow your instructions and make the cup of tea. Now, in a similar process, if I have to ask someone to volunteer and teach someone how to ride a bicycle, and you need to teach that in theory, it is very hard to teach. But it is clearly something that is very easy to learn, but it's hard to codify. These are the kind of problems which are essentially what everybody acquires vocationally and over expertise. What is experience versus qualification, right? So qualification is the rule set. Experience is all the stuff that you are not able to transfer, or you are not able to teach someone by simply codifying it in rules and encapsulating it. It is something that you learn only over multiple iterations of something. And these iterations, we are now able to do it rapidly in millions and billions of transactions to teach machines this. So this is why this is very valuable. And of course, the second attribute is machine learning systems or AI systems are excellent learners. They will learn and achieve superhuman capacity in learning simply because of how they are designed and how they do this. So these two things make it very powerful. And yes, just two approaches. There have always been a lot of research on decision systems and expert systems in the past, but basically there are two approaches to AI. In the past, people have tried to do this based on logic and rules, and they've typically found that all the rules cannot be codified exactly like how you teach someone to ride a bicycle. You can't give them a series of steps in a textbook and then give them a cycle and say, now ride it. It's hard to do. And systems have been failing in the 80s and 90s. So now there is a bottoms-up approach, which is reverse, in which the system learns from what has happened previously by observations. It goes through a series of observations, it goes through a series of results, and then it makes up its own rules in terms of how this process has to be followed to get this output, and over multiple iterations it gets it right. This is the approach that is very successful. That's what is making AI very successful today. So just a quick quick audience check. So we are trying to build a system, think of it like a segregation, classification system like we spoke about, and we are trying to separate the reds and the blues. So assuming red are all high risk transactions and blues are low risk transactions, and you are trying to separate it, and you are building a system. And you can separate it in two ways. When you're building it as a, think of it like a system you're building, and then your office is going to use it for multiple transactions in the future. Which do you think is better? You could either build a system that works like the black line, or you could build a system that works like the green line. How many people think you should build a system that looks like the black line? 1, 2, 3, 4, 5. Okay. 30%. The other 70% are thinking green line. I usually don't ask the other half questions because then we get a third category which is no answer. So fantastic. So someone who says black line, can you say why?
What I would like to say is excellence is better than exacting. The green line takes the exact route, but this is excellence, not perfection. We cannot do perfection in real life. Only excellence will do.
Okay, you're a data scientist, sir. You're speaking like a data scientist.
No, I am only a pure chocolate.
So clearly, so fantastic. Actually, this is one of the best non-data science definitions I've heard of this. So in data science terms, we call this overfitting. So overfitting is where you're fitting your answer so much to the exact solution that when you encounter a next problem in real life, the solution does not apply because it is already overfit to this training data. So I'm going to quote you in, if I do the same slide in the future, like excellence and perfection. So it's exactly a data science problem, because lot of times we encounter this because when we're building systems, the systems work extremely well for the data we've trained it on. And then the first time we actually have to try it with new data, it doesn't work. And then we realize that the system is already like extremely overtrained. And usually systems that work like the black line are better. This is actually a very real understanding. Philosophically, that is something that you need to understand because AI systems will not get 100% right. They don't, but they will get 95% right for 1 billion transactions. They will not get tired. They will do another billion transactions after that, but get 95% right, which is better than any human being or any operator. So this tendency to look at systems in the lens of perfection comes from the software world where everything is rules. So everything is very easily understood and classified and explained in one category or the other. And therefore, this is something that all of us need to keep in mind when we are using AI systems. So which basically means when you use Google Translate 100 times, there are a couple of times when it will make a silly translation. And Google makes more than 2 times out of 100 today, but it will not get it right 100% of the time. So which means if you are preparing for a speech in a language you don't know, you don't want to do it in Google Translate and take it and go read it. So yeah, so some limitations. So some limitations we need to be aware of as well is one, machine learning is not general intelligence. It is very narrow intelligence, meaning if there is a system that is doing OCR, it will only do OCR and only do OCR for the kind of transactions that you trained it on. So if, for example, our system will do only OCRs on invoices in English. So if you give it an invoice in any other language, it will not know what to do. If you give it a different problem, it will not know what to do. It is very specific. So it's not a general intelligence like they say in the movies, like a robot or a superhuman that understands and makes the right decisions for all problems. Those kind of systems do not exist. They are computationally too expensive even today. So that is general intelligence. There's no general intelligence. It is very limited intelligence. Second, data quantity quality is fundamental. So the quantity and quality of data you train the system with is what defines how well the system works. If you train it only with 100 samples, it will not be a great system. Even though it will be extremely good for the 100, it may not be a great system in real. And a lot of the data reflects all the bias and prejudice that we already carry. So for example, when we're training systems to do things like credit evaluation, Apple, for example, is in a controversy right now with its new credit card program, where it is offering women a lot less credit than men. So typically it offers women with higher credit score outside, otherwise lower credit on the credit card. It assigns a lot less credit. There's a lot of controversy going around and people are evaluating the algorithm. But essentially, the problem is not in how the algorithm is, the problem is in how the training data is. So in the past, if you've been discriminatory, or in the past you have seen data that has been like that, the system will continue to do that. It is what you train it to be. And not all problems are machine learning problems. This is something that as a machine learning practitioner I have to tell you, which is not all problems are machine learning problems. Sometimes it makes more sense to just do it the old-fashioned human way, which is typically the case, right? For example, if you have like a really high-value client with a very specific problem, maybe it is better for you to actually take the old-fashioned approach, review the case, make your decision rather than try to depend on a machine. Machine works well for high volume, multiple iteration transactions. It doesn't work well for one-off kind of transactions. So that is something that is to be mindful of. And the outputs are always mathematical. The outputs do not have an ethical framework. The outputs do not have judgment. The outputs do not have what is practically applicable today in today's climate. It does not. The output is purely mathematical. It is a machine. It does not have any of the other senses. So all that has to come from whoever is using it or operating it. It does not come from the machine. So if you make a bad credit decision or a bad decision, the machine does not take responsibility or make that distinction. This is something that we need to be very clear about. Why do we say this? This is something that we find a lot of, especially in transactions like credit decisions. People, while from a machine's perspective, it is simply making a mathematical decision and saying this is above the pass score or below the pass score. For the person receiving it, it is very important. And for the person receiving it, that might be very important. And if you actually, as a human being, you understand the case, you might make a very different decision. So that's something that is to be mindful of. And of course, the most important is the accuracy is also specific to circumstance. The circumstance you're applying it in will define the level of accuracy that you need. So for example, we used to do this solution where we verify people's photos with their ID cards. For some of our clients, where you match two photographs and say whether this is the same person in the ID. So you can do this in different levels of accuracy. So if you're doing it for like attendance, you will do it at 80%. But if you have to do this as like security screening for like say some high security facility, so you are going to do this for like the atomic station in Kalpakkam, you will need to do this at 95% accuracy. The same algorithm cannot be used in both places. The application case decides what level of accuracy you need and what kind of decisions you need to make. So the algorithms are not generally portable. So what we use for OCR is good enough for OCR on invoices and documents. It may not be good enough for some other use case, or it might be too complicated for some other use case like reading a textbook. So accounting itself, right, specifically. So now that we have a broad setting and framework of what AI is and what we're going to do around with AI, specifically accounting, why does it apply? So accounting, in general, this is not my quotation, so some of the quotations I'm saying this is actually by the Institute of ICA EW, England and Wales, and this is from a paper they've released. So accounting is not an end in itself. So accounting essentially is not a direct end output activity. It's what the institute says, and basically it is about making decisions. And making good decisions are what accountants do at the end of the day, and holding other people accountable for those decisions. These are the two functions that all accountants are expected to do worldwide, and this happening well then decides on all other things like growth and confidence on everything else. This is the context. And typically decision making means, since we said decision making has two components. One part of it is intuition and the other part of it is reasoning. And intuition is essentially what you learn from experience. Reasoning is what you learn from data and what you can substantiate with data. And these two together then help you do different kinds of decisions. And when you are an accountant, what are the decisions, what are the typical decisions that you make? So you have typically 6 broad categories of decisions that you make. So there is data capture, there is, which is like typically entry, billing, punching in invoices. There is data generation, which is like collating multiple data, transforming it, doing some work in Excel to join some data to put it together. And then there are reviews, in which case you're doing either a risk review, a tax review, audit reviews, you're reviewing output as an accountant, or you're doing reconciliations between 2 different data sources, AR, AP, TDS, GST, 26AS, different use cases. You're making judgments. You're deciding whether this is applicable, the standard is applicable, does it comply, or you're making a legal judgment, what kind of laws apply, or you're reporting. Within these 6 categories, pretty much, these are the activities that any accountant does. And the color coding essentially is to show you how much of this is at risk of replacement with AI. So the highest risks are at red. So data capture and generation, pretty much machines can do extremely well today. So that is something that you need to look at with a lot of care and build machine-driven solutions around it than human-driven solutions around it. Reconciliation and reporting are in the middle category. There is some amount of work the machines can do, some amount of work the persons can do, the humans can do. Reviews and judgment are essentially where the machines don't have a significant impact today. What also happens is that typically any task or any function that you do has multiple elements of all this. It is not that when you do a tax review, you're only doing a review. You also have to collate data, you also have to do judgment. So every function that you do has all these segments of activities that come in, and that is how all the different AI systems function as well. They help you do some part of the activity. So for example, when we do TDS reviews, we look at ourselves like a company that does like an MRI. So we will do and give you an MRI report, but you still need a doctor to review it and interpret it and tell you what you need to do with it. That doctor typically in our case will be like a chartered accountant or auditor. But the idea is the system is not completely going to take over, but the bulk of the work, which is the heavy volume work of going through 50,000 invoices and identifying which is how much TDS is there for 50,000 invoices, the machine will do. The decisions on what to do, how much should you file, what will happen if you don't file this month, if you file next month, what will happen, do you still have time to go revise an invoice? Those are things that the expert who's handling the system does. And typically why, so in extending that, so there are 2 different parts, right? So there is humans versus computers. Human weakness typically is, one is in judgment, which is what we call human judgment, or what we sometimes substitute human judgment, or we are taking a judgment call for actually lack of data. We are applying experience to fill for data gaps. This is typically something that can be a human error. And denying the potential of computers sometimes is a very common human error, not understanding that the computer can do this much better or much higher, where we're trying to take a competing position with the computer instead of looking at it as a tool that is under our control. But what are our strengths? As humans, we have strengths. We show leadership, we can show empathy, we'll be able to show creativity, make decisions, be practical. These are things that machines don't do well. So these two elements need to work together. Strengths, where does AI really shine? So when you're talking about use cases, these are the three places where it shines. It can handle extremely large volumes of data. It does not have a fatigue. There is no limit. There is no competing with an AI system in terms of volume. These are areas in which you cannot compete, and you should not try. Similarly, complex and weak patterns. It will be able to identify even very weak patterns which are not easily discernible to the human eye. You will be able to look at like 1 trillion transactions and identify 1,000 risky transactions from it. Practically, it is very hard for human beings to do. It's not only a volume problem, it is also being able to pick weak signals well. And the third is consistency. So between every operator or every auditor or every intern, there is a difference in performance. Each person dependency brings in some elements they do well and don't do well. One second, I'm not sure why this is cut off. Okay. Okay, excellent. So yeah, so consistency, these are the three areas which AI systems can bring you. So whenever you're looking for these things, so typically we work with a lot of accounting firms, and the things they come back and say is that we do not now have this problem of saying we have this great audit assistant or this great article clerk, but now he's gone away, so the audit quality is dropped. So consistency, and of course the other two attributes I spoke about. This is what AI brings to accountants. And how can it help? So basically 3 ways, right? It can help with the decision making by providing better data, new, better, cheaper data. It can generate newer insights which are not otherwise possible, otherwise easy to see, and it can free up a lot of time to focus on more valuable tasks. This is very important because one of the things that all these systems bring is they take away a lot of time that is spent on repetitive, laborious activities. The simpler activities which are very hard to do or very laborious. Excuse me, sorry. Okay, so the simple activities are where it makes a lot of difference. So given this context, how should we feel? So as accountants, how should we feel? How many of you think A? Okay, nobody. B? Okay, some people are curious. C? Excited? Confused? Okay, so fantastic. So it is. I actually think this is this classic speaker answer. It is like all of the above. I think you have to feel all of these emotions at the same time, given where it is. So yeah, so just a quotation in terms of just saying this is something that caught my eye. I thought it's very relevant. I don't think AI will replace accountants, but accountants who use AI will replace accountants who don't use AI. So that I think was like a very, very apt quotation, a very apt way to say how it needs to be used. it is AI is not going to become our master, but it's going to become a very powerful tool in our tool set. So just some data in the back, right? So this is from McKinsey. McKinsey believes when they're doing all these different sectors and functions that can be impacted by AI. So 86% of activities that are being done by bookkeepers, accountants, audit clerks are potentially automatable by AI. This is the World Economic Forum from a job landscape perspective in 2022. These are the top emerging activities. I am not sure if you're able to read it, but they are agreeing. So data entry, accounting clerks, payroll clerks are what they are putting in the declining category, and that is something that they are expecting. The good thing is they are expecting 133 million new roles for 75 million old roles which are getting declined. So technically there is going to be a job gain, but in different roles. That seems to be the bottom line. Of course, leading firms have already been making aggressive investments in AI. So these are all different firms or operators who influence the accounting landscape in some way, and they are all making very aggressive investments. I've been a part of some of these in EY myself, but this is just a sample of some of the firms. There are the others as well. So apart from KPMG and Thomson Reuters, I know PwC has been doing a lot of work. Even when we go further, I'll talk to you about how the accounting technology landscape itself is changing. And of course, the market itself is changing substantially. So one, there is a lot of data disruption. We spoke about 90% of the data, and accounting is one of the areas which has been disrupted the least so far. And that usually means that's the area where everybody is looking at for the next new opportunity or the next new efficiency gain, and that's on focus now. Again, I wanted to show you a video of how there are use cases now in cricket. So people are looking at very different places and very different areas to see what they can do. So I don't know if this is easy to follow without caption, but yeah. So Anil Kumble, as you can see, he's partnered with Microsoft to create this company called Spectra, and where they actually put a small sticker on the cricket bat, and that sticker then transmits data, which is then interpreted by an AI engine to be able to say how well the batsman is playing and where he's playing. This is, of course, Microsoft's AI. This is the framework that explains that. But yeah, so AI is coming and influencing in very strange, very different places. So that is the bottom line of what we were trying to do. So from an accounting tech perspective, again, so this is again something that I wanted to talk about in a lot of detail. So this was in New York Times saying the accounting industry's death is like news for your business. The article actually talks about death and rebirth of the accounting industry. It also talks about how it is actually reborn in very different ways, and how there are very different solutions and software which are occupying the space today. For example, there are very interesting businesses now. So there are businesses which are all doing extremely well with a lot of volume. So these are some businesses that are very interesting and curious, which operate in the accounting and finance space. Recurly is very interesting. They let you manage all subscriptions and recurring invoicing type businesses. There are funding startups. Expensify is quite popular in expense tracking. Wave again is extremely popular. You scan your bills, it will do the travel and expense claim. Of course, bookkeeping, Xero is doing bookkeeping, but this is actually the actual accounting tech landscape of 2016. It's unreadable, I know. It was not readable even when we zoomed in, there are so many. But these are all categories in which there are different software and automation today. We've gone a long way from this one ERP or one accounting software world. So typically there are software for each of these functions: BI, payroll, expense management, document management, tax preparation, audit and risk. So there are many tools now, and a modern business tends to work with 4 or 5 of these tools at the same time, and this is already the case. For example, when we decided to do our accounting software, we were very specific that we would not want to do anything that's not a cloud accounting software. They said we need to be on a cloud accounting software. We don't want to be on Tally because we want to see what's happening real time, and we do not want a monthly report in which our bookkeeper will send us a report and then we will see. We need to see today. And how do we see today? So with the cloud accounting software, so that's Tally or a Zoho or a Xero or any of these allow you to do that today. We already use document management for all our bills. So all our bills go into a Dropbox folder or a Google Drive folder from which our accountant's office picks it up and scans it. So already we use a document management system. We already use excuse me, just an announcement.
Sorry about this interruption. There are 2 vehicles which need to be moved. They are blocking the way. PY01AS9509 and TN85B3070. If you could just help us. Yeah, thank you.
So these are all places where people have all been changing and using modern tools now. So the traditional functions are getting challenged because there are tools that do this well. There are traditional ERPs and traditional accounting software which are constantly losing market because they don't have features that somebody else is giving away very easily. So for example, document management, pretty much everybody starts thinking about scanning and using a document management system now. Workflows and bill payment software are very common. Time and expenses, again, is a very common area where everybody is using new systems. And one of the things that also happens when you use multiple new systems is that all the data gets digitized, and all the data also gets portable from one place to the other. In India, for example, one of the biggest drivers for digitization has been GST. Because of GST, people are forced now to make sure that all data is available in a digital manner. All the data is now captured and available for analysis as well. They are also available for analysis. They are also available for building AI systems on top of it, which was not previously possible. And even from a government perspective, government has also been doing a lot of work in adopting these technologies, whether be it GSTN, be it the CBDT. They've been doing an extremely aggressive amount of investments in these technologies themselves. I was fortunate to be part of one of those projects with CBDT, where we were setting up a data intelligence team for CBDT, where they have a 400-member team providing data intelligence, looking at taxpayer data, and we did some pilots and trials at some state governments where we looked at very interesting things like looking at power consumption of factories versus the revenue they are reporting, or input consumptions from different departments, different government departments, and then collating it to say what should be the projected sales and output for that year versus what are they actually declaring on their income tax return, and whether it makes logical sense or not. So government has also been making great investments in this area. So which means the industries that are working with these departments also need to be able to reflect and arm themselves a little bit with these technologies. And of course, the The other part that I was very specific about is the fact that we are in the new economy, which means there are new problems which need new solutions. So, for example, Apple Store or Google Play, as an auditor of Apple, you are going to get now, Apple sells, for example, apps, it sells songs and music at like very small prices, less than $1. But it's when you look at it from a normal materiality framework, it's not material. But they sell 2 billion songs, and they sell like 2 billion apps. So now you have a large chunk of revenue. So you're talking about some $5 to $20 billion of revenue coming in microtransactions. So your normal sampling or materiality filter will not work. But at the same time, you cannot ignore it because it is too large. Collectively, it is very material. Individually, it is extremely small. So the logical way to do it will be to do something with machine. And this is the only way in which you can actually get control over a transaction set like this and look at whether revenue that is being recognized from something like this is actually accurate or practical. Similarly, e-commerce sites, when they do a big billion sale, they are talking about like a large volume of transactions, close to like $7 billion was like last year's Amazon's Black Friday sale for the one day. Similarly, in India, we have many stories like that, 1.5 billion rupees of sales over multiple transactions, multiple values, multiple categories of items. All of them are discounted, which means there is actually a different gross value on which you need to pay tax. There is actually a different market price, there is a different price that is being charged, and there are differences in discounting. And these are all built in one location, shipped from some other location, sometimes not even shipped by Amazon themselves, they are shipped by some other third party, so which means it's a marketplace. Now all these complexities are typically things that you face in companies in 1 or 2 transactions or 10 or 20 transactions. Now you need to face this in millions. So this is again a practical problem that is now driving new technology changes and a new approach to look at these things. Hotels again are a very interesting business. Oyo, Tribo are all very interesting businesses. I used to have a lot of interactions with some of them. For example, their pricing is dynamic. So pricing in these hotels are like airline. When you log in, you will get a price. You log in 2 hours later, you will get a different price. So how do you decide which is the right price? How do you decide which is the right amount of discount? And how do you project revenues for this business next year? All this comes from a data science system at the client side. So for example, in Tribo, they have a system that scans, and look at data from multiple other hotels. They look at multiple other travel websites, and they put all that together to arrive at the price at which they should offer that hotel in Bangalore at that point of time. So which means that if you have to review whether that pricing is accurate, should this have been 700 rupees, should this have been 2000 rupees, you will have to do the same thing to be able to even identify the same decision. Otherwise, it's very hard to do. Of course, the most important is the sharing economy, which most of the startup world keeps pushing people towards, like Uber or WeWork, or there are businesses, so you buy pretty much everything on subscription. You do not actually spend capex at all. You do zero capex or close to zero capex, but everything is paid for in subscription, which means you need to find new ways to account for this. Your volume of expenses are going to be much greater than your volume of investments. You are not going to have any depreciation, but you are going to have like a crazy amount of expenses. So we ourselves are one such business where we are where all our servers are on subscription on the cloud, all our software are on subscriptions annually, all our rent and all our capital expenses around building, office don't exist. We pay a rent for a workspace which is fully fitted out, hot desks, which means internet, AC, everything is paid for in subscription. So our accounting interpretation and treatment itself is very different. And a lot of our bills directly come from providers directly as APIs. You don't really need to do the old-fashioned print a bill, look at it, punch in the entry again. You can actually pull the entries directly from the system. So for example, Uber offers employee travel expenses to directly connect with Uber's API. So for example, in Deloitte, I think in Chennai, you already have that. So if you do Uber and you put Uber for business, your car rides directly fall into the T&E system. And then all you need to do is to say which project it is for, and you're done. So you're really not actually uploading a bill and claiming anything. So this is the third. So these are all differences that we've seen. And I also wanted to talk about some of the use cases, but I just wanted to check, do we need to take like a quick 5-minute break and then restart? Can we continue? Would you like a 5-minute break? I know we've been speaking continuously for some time. Yes? How many people want a 5-minute break? Okay, please take a 5-minute break. We'll come back. It's 9:55. We'll resume in 10:05. Yeah, can we start? I think we have some of our members waiting to come in. Just please give us a minute to wait for some of those people to come back in. Okay, so while we start, any questions, any comments so far?
Blockchain, where does it fit into this artificial intelligence? Blockchain and distributed
Ledgers.
where does it fit into this?
Okay, so blockchain is essentially it doesn't really fit in this in the AI scheme really. People like to block it all, put it all together because it is more like modern technology. So AI blockchain is spoken together, but really they are two completely different schools of thought and completely different use cases. Blockchain tends to replace how you store data, so it becomes a bit of a database alternative. And one of the big purposes it solves is that it doesn't have like a data keeper. So the data kind of maintains itself, maintains its integrity, so there's no central authority who really owns the data or maintains the data. AI does not really overlap. The overlap is very minimal, meaning if you have a blockchain based storage of data, your ledgers are stored in a distributed manner, then getting that data for transactions and interpretation is the only area where I really see an overlap. The data storage system really does not impact AI functionality. The only thing is that central data stores tend to get replaced by distributed data stores, and because you have distributed data stores, then this whole access to data for training AI systems and things like that can become complicated. But that is given that blockchain is also a very early stage technology, in fact far more nascent compared to AI, and far more harder for people to adopt and use because of the very nature of how it is, which means a large number of people have to collaborate for distribution systems to work well. Distribution does not work well if two operators decide to do blockchain. So blockchains are strong only based on the number of people who are part of the blockchain. So which means adoption of that is going to take even more time compared to AI, where somebody else runs a pre-trained model and gives it to you directly to use today. In a blockchain system, the maturity of the system itself will take time, unless you are going to join an existing ledger network or something. So for example, if you're a supplier for like a large industry group, you're some supplier for Mahindras, and Mahindras have adopted blockchain for maintaining supplier ledger, and you join it, you will get it. But if you have to implement it, it is very hard for you to go convince a lot of people to adopt this new ledger. So it's got a lot of practical challenges in terms of how it will work. It works well only in very large central escrow type situations. It doesn't work well in bottom-up type use cases. It works well in top-down use cases. So I don't see too much of an overlap. My short answer is it's a data store, so it does not really impact how decision making on top of that happens. But good thing is that some of these attributes which you have to review today or verify today as an auditor, you don't need to verify because the blockchain system's design itself kind of takes care of that. So you don't really need to verify integrity of data because the system structure automatically keeps the data in a secure manner. But it's the practical outputs of blockchain data are very, very rare and very hard to see. Any other questions before we resume? Okay, so let's get started. So I just wanted to talk about some practical use cases different firms are adopting. This is something that's happening in PwC. They are looking at it in many different ways, but these are not just PwC. A lot of the mid-market firms have also started looking at it. It's not only the big four firms, but they are looking at redeveloping existing services. Which can we look at existing services in a better lens with AI? For example, can some of our advisory services be provided through AI? They also looking at a large scale back office support. Can we build central teams or central back offices or centralized support for a lot of our services? This is something that has extensively taking place in the big four firms, even in the slightly largish firms, because we are part of a lot of such projects ourselves. I've been a part of these in EY for even 5 to 7 years ago. So, which is to set up central centers of excellence where a lot of the data processing happens through machine. And when you're actually providing some of the services, it's being provided as a managed service. So the customer does not really get a view, the client does not really get a view of whether it's done by machine or done by hand, but a lot of work is being done by machine. For example, we used to have this, and it also comes up and creates a lot of new service offerings. A lot of novel new service offerings are possible, specific to industry, specific to use cases. One of those that we used to do a lot of work in EY used to be for media and advertising spending. So for all the companies that spend large amounts on advertising on TV, they have a huge budget, and there is a very complicated reconciliation between the bills they get from the ad agency versus when the ad is actually shown on TV. So for example, if you paid for an ad slots are paid for depending on the time and place and the correct event at which it's broadcasted. So for example, in a cricket match, if you're paying for something that is being shown at the fall of like one wicket, you have to show an advertisement. That's a separate premium for that. Versus what you pay for when you pay in between overs, versus what you pay for in a lunch break. So very specific performance of that category is very important. There are rules like if you are Pepsi, you do not want your advertisement to be immediately followed by a Coca-Cola advertisement, because the general belief is that the last advertisement is what the buyer will retain. So all Pepsi's effort will also go into selling Coca-Cola. So there are some rules around it. Apart from all the regular payment performance, because TV channels are also very complicated. They're all groups. So they will do things like, if you buy in NDTV, you will get 3 ads free in NDTV Hindu. If you buy in NDTV 24/7 main. So these are all things which have to then be verified when you're verifying these bills. And when you're talking about like some 400 crores of spend for some company like an HUL, then there is a lot of effort that needs to go into reviewing and auditing this, and most of these are pre-audits. So you audit it before the vendor payment takes place. There's typically a 90-day credit period. So these are new services, and these are service offerings that firms come up with and offer. This is a service that used to be offered in EY, entirely driven by technology as an audit review. Typically, for a 400 crore review, you could easily charge a very, very large amount of money at a very high margin, because when you see it from the advertiser's perspective, the cost of control and pre-audit over it is very small. It's 0.1% to 1%, between that, depending on how much volume you're doing. But the cost of actually providing that service is extremely low because it's done fully by AI. And these are new services firms are all looking at, but a large amount of effort actually gets done in the back office part of the work. For example, one of our clients used to do a lot of this TDS compliance reviews for AP, where they used to actually have maybe 12 article clerks working continuously for like a month, review all the bills, capture all the data in an Excel sheet, make the analysis on top of it, and then send it to the client and say so much is TDS you've not deducted and so much is the money you need to then pay and make entries for it and rectify. Now this process has, after they've adopted our this thing, the number of interns from 12 has become like 2 interns. So they use 2 interns and then our system to do a bulk of the work. And this allows them to do what took like a month to be done in like 1 week. So the amount of time is saved, there's a lot of amount of money that is saved, and a lot of this is also extendable, replicable. So now they used to always have a problem because 12 interns itself is very hard to find for any firm to deploy on one project for a month. Now they're able to go and take on like 5 projects of the same type at the same time. It allows them new space and capacity. So some very interesting use cases like that. Goldman Sachs and a lot of the banks, eventually investment banks start first, but all the banks eventually adopted. A lot of the processes are now getting automated. Goldman Sachs has put like a process list and said some 127 process steps are there in an IPO, typical IPO process. If you go to Goldman Sachs as an investment banker, they are now cutting that by half. They are saying 50% of that will be done by machine, only 50% services will be done by people in our organization. Linklaters is a legal firm, and a lot of the accounting world has actually been slowly eating into the legal world. If you've been following it generally, you will notice globally all the big 4 firms have started acquiring law firms. They are making a large investment to start becoming accounting plus law firms. What they feel is that they should manage all the compliance for clients and not only manage accounting compliance and then say you go to a lawyer for legal compliance. Firms are slowly expanding their footprint, and one of the things that they are also doing while they do it is to use a lot of AI for all the reviews, to review documents and to review contracts through machine systems and identify specifically. For example, AI is very useful to do things like to review a contract and say, is there a force majeure clause in this contract? Have you put it? It is very easy to review through machine. You don't really need to actually read through 500 pages of contract to see it. The machine will scan it and say there's no force majeure clause. You need to add it. These kind of checks are very easy to do, but these used to be very large effort that you need to pay to law firms for, and they'll put an intern who will read it and circle it and pencil it, and somebody else will review it. Now this process is being cut down substantially. So these are some use cases that different industries that we've been seeing. In the accounting services itself, there's a lot of work that's happening in the reconciliation phase, particularly for GST, because there is a lot of practical difficulty and gaps. There are multiple startups which are trying to do work in the GST space. Pretty much from when GSTN was started, there's been a lot of effort and activity in this. And reconciliation tools really allow you to be able to do the first level pass with the machine and say this much is clearly matching, take it out, and then start working on the ones that are somewhat matching, and then work on the ones that are not matching. So at least if out of 10,000 transactions, some 7,000 match accurately, you don't really need to worry about it. Those the machine will take care of. And you worry about the 3,000 that doesn't match, and in that it will tell you how much of that is not matching because there are just small variations, either in spelling or there's a sole proprietor, so his GST and PAN is in his name, but the business invoice is in some other name in your ledger. So these kind of problems are all very easy to codify and train the machine to look at. And then what is left is what you're actually going to apply your judgment and review. So this is something that we commonly see. We see a lot of work in converting bookkeeping output to MIS. A lot of clients find it very hard to generate very clear, meaningful MISs, especially when they do a bookkeeping for some international company, which already comes with a format and says this is the format in which you need to give an MIS. How do you sit and do this? Today is essentially somebody sitting and slogging it with Excel. and then there's like month end and deadlines and things like that, then this becomes very stressful. These are all again things that people are looking at machines to do. These are some of the use cases. There's a lot of work in the auditing phase itself. Audit is a huge area where there's a lot of investment that's been going on. There are a couple of firms that are doing it apart from us worldwide, who've been looking at bringing in AI reviews on transactions and identify risk scores. Essentially look at all these things, like typically what you will look at as an auditor: material transactions with different risk parameters, identify and risk score all of them, and be able to say these are the high risk transactions you should look at, irrespective of whether you're going to look at samples or whether you're going to look at anything else. This category of transactions you should look at for sure. And because you're doing all this in data, you're also able to neatly synthesize all this data and give it out in a manner in which it can be looked at very deeply. In a lot of large firms, the signing auditor gets very little time and very little insight into the data he's signing. So a lot of these systems give you dashboards that allow you to very quickly drill down and look at transactions. And if you look at a transaction, say this is high risk, can I drill down and immediately look at it? Can I go directly till the voucher and see what is wrong in it, so that I can make a decision right there, instead of having to rely on like a 3 or 4 tier of staff and managers to do that. So a lot of advancement in this phase, and OCR again is something that there's a lot of strides that have been made. So any kind of problem which involves scanned documents being read and interpreted by people, there is a lot of opportunity to do that with AI today, and very efficiently and very well. It's not 100%. But it is very easy to be able to segregate and say we can reduce 40% of the effort, because that 40% is done extremely well by machine. The other 60% is what needs to be done by human. Instead of actually being able to say we will do 40%, but we can't tell you which 40%. The good thing is you're able to segregate, so which then allows you to be able to compartmentalize and do well. So these are some use cases that we've been seeing, and some background because of how AI is and the nature of AI. There are some caveats that everybody need to follow when you're doing work with AI, or anybody offers you an AI solution. Fundamentally because there's a lot of hype around it, so you tend to get a lot of, it will change the world completely, type messaging and positive messaging very well, but you don't get enough caution caveat along with it. So there are some rules. So one, these are some of the rules. You need to work with AI, you can't work against it. You need to understand that if you are putting yourself in a situation where you're working against an AI system, you're going to have like a lot of complications. See, they do not challenge decision rules. They apply these rules in scale, and they don't actually challenge or make decision rules. The AI system is not going to come and say, why should I do this, or does this even make sense? That is for you to do. The system will do simply what you tell it to do. A lot of times people don't understand it, because after some time, after some 2 months of doing it with the system, people basically just simply assume the system will take care. Sometimes it doesn't. And it will do it at scale. It will not apply well for one-off transactions. So if you have one transaction and you want to check the AI system and see if it will get it right or wrong, and based on that you need to make a decision on whether you're going to adopt it or not, it's probably not a good idea. If you're going to evaluate an AI system, try it at scale. So try 1,000 transactions, see how much it gets right out of the 1,000. If you try one, and if it gets it right, that may not be proof that it's successful. If you try one and fails, that may not be proof it's failing. It's a scale system, it's not a one-off system. And second is, it works extremely well on track. It doesn't work well off-road, meaning it works well for what it's trained for. It does not work well for things it's not been trained for. It may not work well for sudden changes in direction or sudden change in requirements. So if you're building a system for one purpose, do not expect it to work well for 3 other purposes, even though logically they may be very similar to you as a human being. What I'm saying is that it might be very easy for you to understand it. It might be very easy for a person who's following these instructions to be able to understand another rule set. The systems actually don't cross over knowledge like that so easily. Training is of course limited by limitations of the trainers, so which means the guy who's training it needs to have some amount of knowledge of what he's being using it for. So for example, this is one of the reasons why we actually end up doing a lot of work in the OCR space, because it's not that the software companies don't understand OCR, they understand it very well, but they do not understand accounting. So they do not understand which parts of the document are very important, which parts are irrelevant. For example, vendor address on the invoice may be irrelevant because we have the vendor address anyway in our vendor master. You don't really need to OCR it so well. If you don't get the names of places perfectly well, it doesn't matter. But for an OCR company, all parts of the document are treated equally. Only when someone has domain understanding, then they will know that GSTIN you need to get right. It's okay if you don't get the vendor's address right. You can still manage. So those kind of practical domain knowledge is something that is important when you're building these systems. You can't leave it to a data science team to completely build it. And of course, bad data is very hard to deal with. However great your system is and however great your insights are, if it meets bad data or it meets data that's not structured well, it will not work well. So for example, we have this practical problem when we're doing OCR. So in a lot of these firms, they will sit and put one invert date and one rubber stamp and one process paid rubber stamp on these invoices as soon as they get it. Sometimes they will go put that rubber stamp on a critical field which we are trying to OCR, so you can't read it. So the bad data problem you cannot solve. But if somebody who's sitting and reading it can look at it and say, okay, rubber stamp this is rubber stamp and this is print, my OCR systems do not do that. And those are problems that you cannot solve. That's not fault of the AI system, that's just bad data. And of course, most important, it's very important to make sure that the model works well. Horsepower is not so important, meaning if it does extremely well in 7 days and someone says I have a model that will do even better in 6 days, 7 days to 6 days may not be a most important function for you. Accuracy from 95% to 98% is probably more valuable, or 92 to 93% is more valuable than horsepower. So whenever you get AI systems which are advertised as better because they can handle larger volumes, they are faster. In AI, faster is not a big deal. More accurate is a bigger deal. And these are some of the parameters. And specifically, as accountants, what do we think are things we should do directionally? Of course, old-fashioned Darwin. Species that survive are the ones that adapt, not the strongest, not the most intelligent. This is keeping pace with the change game. Like I was talking about the accounting tech landscape, this is a reality. Most clients are going to demand, they are going to adopt new technology and demand that their support systems also cope with it. And for example, my accounting, though I'm a chartered accountant, I rely on someone else to do my accounting bookkeeping, and I expect him to work with scanned documents in Dropbox. I expect him to work with the cloud accounting system because that's what works for me. And I can safely say this for at least 10 other startups that I share my workspace with. They all will demand that of their accountants because they are all in that mode already. So our data is already on the cloud. We can give you all the invoices that we are making out directly from our production system. Why do you need me to give you a printout, or why do you need me to scan it and put it in a folder? We won't. We will give you the documents, you directly code it. Or can you open up the API in the accounting system? I will directly push all my invoices into the system. You don't need to even do bookkeeping for that. This is a practical reality that we all need to understand. There are some new roles and skills that need to be learned and adopted. Clearly, this role is already changing. Institutes are all recognizing it, whether it is the AICPA, ICAEW, or even our ICAI. are all very clear that there is a lot of work on the data and analytics space that accountants need to do. Eventually, this will come as part of curriculum. For example, in CBSE, Python has become the default soft programming language for computer science students already, and there's already 2 streams of computer science in CBSE for 11th and 12th students. You can either do computer engineering type computer science, or you could do information processing type computer science if you're in the commerce stream. You still do computer science, and you already do work with Python. So supply of Python talent is only going to go up. You are going to get a lot of people who are going to come pretty much out of school with Python skills. So when they come to articleship on day 1, they will already know what to do with Python. So that is something that the industry basically just needs to be ready and prepared for. And this is already here and now. And look at leveraging technology for repetitive tasks. There is a part where it's already at a point where labor arbitrage is probably not a good idea. Being able to throw labor at it is probably not a good idea already at some of the problems. And look at like review and audit. Reviewing and auditing AI systems is again a requirement that's going to come and fall on chartered accountants as gatekeepers. So your clients are going to put AI systems and then expect you to do audits of that. It is not only about you using AI, it's also about you understanding and auditing AI. And for example, if you're an auditor of Tribo today, you are going to have to audit their revenue only by understanding and using AI. You cannot audit their pricing. Why is their revenue 20% lower than last quarter? Because of pricing is 20% lower. Why is pricing lower? Because it comes from the data science system. This is the answer the CFO will give you, and you need to validate it. And this is a reality, and more companies are going to adopt this, and the more they adopt it, the more people who are gatekeepers and scrutinizing it are going to have to learn this and use it as well. And startups are a new category of businesses which a lot of firms will start working with and looking at. The traditional industries are not the only client segment, and these companies already do technology, advanced technology and data science and AI on day 1. So they are going to come back to you with very new kinds of data and new kinds of systems as well. So what should we do? I mean, this is also as much an opportunity as it is change. And what are some of the things that we can do in this age? One, we need to get beyond Microsoft Excel. Microsoft Excel is not the end limit of technology. Definitely accountants and accounting firms have to go beyond it. Get used to much larger data volumes. Bigger than Excel is like default. You need to do bigger than Excel. Most companies do much more than Excel can allow in one spreadsheet. And use more modern tools. You need to have that at your disposal either by yourself or by somebody in your team. You do need that skill today. You need to learn to use approximations. You need to be able to make decisions a little bit with probability, like we were talking about overfitting, excellence versus perfection, right? You need to be able to actually apply that practically in decisions. You need some understanding of probabilities, some understanding of confidence intervals, 95% confidence versus 90% confidence. You need to know that a little bit. You need to go deeper in specialist areas. This is again counterintuitive, but this is actually very important. You need to be much stronger in standards, much stronger in laws, much stronger in very domain specific areas, because these are places where your actual value and expertise are going to come in the future. They are not going to come in your ability to execute work alone. So, and domain again. So similarly, if you have like very specific industry knowledge, telecom sector or airline or retail, that's more valuable. Business specifics are more valuable compared to compliance and process. The lower end activities are going to become less and less valuable, more and more commoditized. And of course, like we spoke about, understand there are limitations to AI and be skeptical about AI at a healthy level. There is going to be data gaps, there will be biases, there will be errors, and there will also be economics around AI, which is why it is happening. So this is something that as accountants you will all need to be mindful of, but it's a great opportunity, and I think this is something that all of us are probably going to encounter and adapt and prosper in the next 5 years. So that's all I have. I know I've run a little ahead, but I didn't want to overload on case studies and overlap on the same thing, but I'm very happy to take as many questions as you have, so there's a lot of time. Any questions?
You could take us through some case study also, sir.
Sure. I mean, I can still talk through some more case studies, but any questions so far?
You mentioned about
Yes, sir.
reviewing and auditing AI systems. That itself is a one-day seminar kind of thing. So I would request Revati Raghunath, council member, to arrange a one-day seminar on this topic with the main faculty as. That's
Sure.
very useful.
Sure. Yeah, it's definitely, yes, sir.
As accountant, should we learn Python? Should we be tech savvy to survive in the market?
See,
Because you said reviewing, all this like this new.
See, Python, as an accountant, I think before learning Python, I think Python is probably the third or fourth step in your knowledge tree. The correct this thing for that will be, let me just quickly show you that slide. The maturity model slide is the right framework to talk about it. Yeah.
So as accountant, what are the skill sets required?
See, you definitely, like I said, so you definitely need to move in this fashion. So which means you need at least like a tool apart from Excel. So you need ideal tool will be like a Power BI or a Tableau. I'm not recommending one or the other, but in that category, you need a data analysis tool, a basic analysis tool, which is almost necessary today because most of the time you're going to get data that is bigger than Excel. That is one. That's probably the first. And once you've been able to use this well, is when Python will really start becoming useful. See, Python is coding, right? It's not very intuitive, which means it's actually like learning a new language. You are actually going to have to spend a little bit of time before you realize results. As a professional accountant, you're not going to be able to realize results with Python very quickly, but with a more user-friendly tool like a Power BI or a Tableau, you will get more value and faster. Python is something that you can take up once you have used one of these tools. But ideally, yes, eventually you are going to have some Python support in your team. Is that something that you should personally learn is a different question. Because there is actually a complex learning curve, and at the same time there are young graduates coming out who are going to be available at like a very competitive salary level for you to be able to hire. So ideally speaking, that is something that you should look at as something that you can do and extend. But yes, eventually, yes, it is Python, or Python is the tool of choice. That's what we use a lot. It will be great to learn and use it, but it's got a learning curve. So you're going to look at like a 3-month to 6-month time frame before you're actually able to start getting practical value out of a Python. But for something like a Tableau or Power BI type tools, it will probably be 2 to 4 weeks.
Adding to that, I request the council member to arrange training of this knowledge seminar, because as a accountant, Power BI, Tableau, I think the licensing cost is very high from Tableau, I guess.
Actually, for learning, no. You can still go and learn with
we did conduct a session on Power BI, but not many people have turned up to that. But Python we are doing, and like Sir said, we will be doing one on AI and Power BI. See, the focus is now shifting towards IT for audit, tools for audit, AI, RPA, we are conducting. So if you give in more such people, we will definitely be doing it.
Because Tableau license is very costly.
Tableau is expensive, yes.
Tableau is not
yeah, it is
for
expensive.
accountant like me.
See, I mean, so the point is, this is, I'm not supposed to really recommend one tool or the other, standing where I'm standing, but there are one, learning it is not expensive. Second is, there are different tools at different price points. So from my understanding, Power BI is not as expensive as Tableau. It's probably more viable.
Just give a few minutes of any off-the-shelf AI tools which are available, which could be used, by auditors, mid-size firms.
Sure. One second. There's one more question. Yeah.
Just to help them out, not adding because you wanted
You need to be a little louder.
Sorry, what I was saying is of these tools, primarily coming from a tech background, just to answer your question.
Yeah, please.
To answer on from a licensing part of it, I'm not saying Power BI, just that Power BI Pro is a platform Power BI Pro, which is $10 package. That's an option. We've evaluated a lot of Tableau, just click. Power BI is a big company, of which if you are interested in something that is doing at a lower cost, Power BI Pro, which is a $10 package. That's the problem.
Yeah. So Power BI is at this point not very expensive, but if you really get into trainers and if you get into data analyst groups, they will tell you one tool is better than the other or another tool is better than another. There are choices, there are alternatives and choices. But to begin with, I think they all are the same. They all give you the same extension of skill or extension of skill and capacity to process data by about 70-80% over Excel, and that's, I think, very valuable.
So data analysis is the current buzzword. I understand that it is implementing through AI. Am I right, or can you throw some more light for the benefit of audience? What exactly these two are?
Sure. So data analysis or data science, as people use it today, covers the whole spectrum. So people start data analysis pretty much from when they start using anything like Power BI, which is the first step after Excel itself. People say we do data analysis. And there are people who are doing data analysis functions or FP&A functions, for example, in companies with Excel only. So there is already some work around the space. As you grow more and more complex predictions, meaning you're trying to forecast, you're trying to predict, you're trying to adjust for things like seasonality, then the complexity starts increasing. AI is at the highest, both in terms of complexity and in terms of impact, as you can see, both in terms of the value it will bring you, also in terms of the complexity and effort that you need to take to build it. So that is the curve. So normally when someone says they are doing data analytics, that is like basically somebody saying I am doing medicine. So medicine starts from pharmacist to chief surgeon to hospital management, everything is medicine. So you are in the healthcare industry, but it depends on what you're really doing. You're not a neurosurgeon, you may sometimes not be a cardiac surgeon, you may sometimes not be a doctor. Depends. So data analysis is broad like that, it's like healthcare.
One point you were mentioning about limitations of AI.
Yes.
One of the limitations you said is outputs are always mathematical and not ethical. My question is it not possible to codify ethics also and then give input to the machine so that it will learn ethical rules also? Is it in the offering or is it possible or never possible?
Okay, so I think there's a very deep question, which is output is mathematical and not ethical. So is it possible to codify ethics in the system itself? The answer is yes, it is possible, it's true. In fact, a lot of practical systems do that. So for example, when you are doing a self-driving car, one of the ethical things you need to codify is to make sure that you don't actually hit a person or a car that comes in your way, and if you are in trouble you need to stop. So some of it is codified. But having said that, that limitation is one. It is not possible to imagine all the ethical boundaries when you're codifying it a lot of times. And it is not possible for coders to identify a lot of the ethical boundaries around this, which is why the domain expert and the business expert becomes very important. So for example, there is a very common decision boundary which is used. For example, when you're doing an analysis, there are some results you want to avoid. There are some results which are okay. So to give you a very practical example, in audit, when we're doing risk scoring of transactions, it is okay for us to go and say a transaction is risky, and for the auditor to review it and say, okay, it's not actually risky, no problem. By mistake, if we say it is risky, meaning if the system makes an error and risky, calling it risky. But if the system makes an error in saying this is not a risky transaction, it's a great transaction, and it goes through and something goes wrong, that's a problem. So there is a decision boundary that's constantly being applied in all AI systems. There are some results which are okay, there are some results which are not okay. For example, it is okay for you to miss your flight. It's not okay for your flight to crash. There are two different problems. So you are always optimizing for making sure the flight doesn't crash first, and then only make sure passengers make the flight. So some amount of is codified. Is ethics codified? Yes, ethics are codified. But what it does not do, for example, in a credit rating decision, or for example, if I go and do a review of all your customers and give you a report saying these are customers who are most likely to default for a loan portfolio, or employees, these are most likely to quit, attrition analysis of a company. If you go and take penal action on top of that based on that AI report, that's where the problem starts. The report actually gives you a mathematical output and says these are the highest probability, above 70% probability, this is the group. Now, the ethics have to come into play in terms of whether is 70% a good cutoff or not, first. Second, the ethics have to come into play in terms of what is the penal action you can take because there's a probability this person is going to quit. Or a positive action saying I'm going to give everybody a bonus and retain them. Is it a good idea for the other group that's actually not at risk? Is it fair for the other people because now the AI system said this guy is at risk, I'll give him a bonus. So the fellow who's not at risk, what happens to him? So it's a complicated problem. It's not simple and straightforward. But baseline ethics are codified. It's not that the zero ethics codification. Some amount of ethics are codified, but not all of it.
So what do you think of audit tools versus AI? A very simple question.
See, audit tools versus AI. See, audit tools, today audit tools is a very loose category, which is ACL, IDEA, typically caseware, the two that really fall under audit tools that actually do anything with transactions that you're going to do audit with. Most of the other audit tools that fall in this category tend to be more workflow, work paper management, workflow, like casewares, CCH, offer these. The audit tools tend to offer you extended Excel type functionality. They don't really do any audit or analysis for you. What it allows you to do is to do better than Excel is what they offer. Two things they will offer which Excel doesn't offer. First thing is, Excel will not give you an audit trail. If you do 5 steps on it, you can actually make a record and log of all the 5 steps that you made, which you can't do in Excel all that well. Second is they won't change the data. So your original data remains intact while you're doing all your audit analysis on it. Sometimes in Excel when you're doing analysis, the data itself will change. Which means if you don't carefully retain your original data, you could actually lose a lot of the data and suddenly be working with data that's not your source data. These are the two problems that audit tools really solve. Other than that, they don't really offer any input or analysis directly. But if you get to more advanced ACL or advanced idea type things, they bring some libraries which are pre-built to be able to do the analysis on it. And it allows you to also build a team that can codify in ACL and then repeat across audits or repeat for audits. But essentially, it is the same as Python. So if you do the same thing in Python, you could still achieve the same results that you achieve in an ACL with Python. If as a firm you are looking at investing in some of these audit tools, you should definitely look at investing in regular software because they will offer you all this. Other than the fact that they are branded as audit tools versus some of the software is not branded as audit software, they are branded as just software, there is really no difference. But AI is a different thing altogether, where you're actually doing things that you cannot otherwise do without that system, which is you can't read a scan document and read data from it, or you can't identify risk attributes of a transaction by simply loading it into the system. Those are the benefits that you get from an AI system. AI is actually where you're replacing judgment, which is what is preventing a lot of accounting firms and auditors from automation, because the judgment comes very practically. The team knows, my team knows how I do work, we know some logical boundaries, how do I sit and codify all this in a system? So this problem AI tools solve better than audit tools. The audit tools today are trying to build all these AI features into it. Maybe in a few years from now, you will be able to do a lot of this directly from some of these tools themselves. But as it stands today, it is probably better to go general purpose software like Python than to go towards an audit tool. Yes.
I have already a number of accounting processes. How does AI integrate or it works as a separate?
Sorry, I am not able to catch your question fully. Maybe you can take the mic.
I already have a number of processes and accounting tools in my business. If I want to take AI into the business, how does it integrate or it works separately?
See, what accounting tools do you have? Could you be a little more, could you explain?
SAP and
Okay. Okay, so it integrates, see, integration of systems is something that happens anyway. Whether it is AI or whether it is a Tableau or whether it is any new tool you're bringing in, it means there is some integration work that has to happen with your existing systems. That is standard. But most tools, most AI type tools tend to have an option where you can upload Excel or upload CSV, upload text files or Excel files. Excel files mostly you have other formats because Excel sometimes will have limitations. You have 10 million lines, Excel can't fit it, so you need to put it in some text format and load it. So straight away you will be able to use it. But if you need a day-to-day application, meaning as I punch a transaction in SAP or SAP, I need to immediately risk score that transaction, then you need a more tighter connector. Connectors are possible, they are available and possible to be able to integrate. Integration is not a very big challenge from a excuse me, from a feasibility perspective, but the complexity of your ERP and IT structure will make an impact on the complexity of the integration project. If your SAP licenses, what it means to pull data out of SAP into another system live, these are some challenges that need to be addressed. But to start with, you should be able to export data out into a text file or Excel file and load it and use it straight away. Yes.
Generally, what are the, we are talking about the AI, what are the courses actually available which is useful for the chartered accountant to learn more about the AI?
Courses that chartered accountants can do. There are a few. See, a lot of the courses tend to be very hands-on technical courses. They may not necessarily be the best to use on day zero. There are some courses which are better, which help you in understanding and interpretation. There are some of these courses online. So, for example, there is one in deeplearning.ai, which you can go look at. Deeplearning.ai has a very good course for non-coders, non-practitioners, where you're learning about AI and how to work alongside an AI system or use an AI system. That's a great course. There are a few other courses online, but it's subjective. Some work well for some people, some don't work well for some other people. It depends on your own interest and effort that you want to put in technology. But deeplearning.ai has a very general purpose course. Some of these institutes are now slowly coming with analytics courses for senior management, analytics courses for more hands-off people, but early stages now. See, UiPath is RPA. UiPath, Automation Anywhere. Microsoft is coming out with its own thing now called Power App. They are all RPA. RPA is not decision science. RPA is just automation of process. So it is ideal when you are running like a shared services center, or ideal when you are running a back office type work, where you are able to repeat processing. The biggest benefit that UiPath or any of the RPAs bring is, you have one person working for 8 hours. Now the machine will work 3 shifts, 24 hours. The amount of effort that you can get out of the machine when you replace it with replace a person with an RPA is 3x, because 1 shift versus 3 shifts. That's pretty much the bottom line of what they offer. Apart from that, everything else is really not on the offer in terms of decision making and all that today. Yes, ma'am. Difference between RPA and AI, I did have a slide somewhere. Just 1 second. Yeah, so very, very simple. See, a lot of the RPA has branding that makes it sound like AI. Say they either call it like intelligence, they call it automation and all that. But really speaking, RPA is like old-fashioned software. Okay, RPA is underlying code is very similar to what you use in Excel macro. Same VB script, in fact, which is like how you record a macro in Excel, right? You put record, you do 3 things, and then you run the macro, it will do the same 3 things again. RPA is exactly that. It will record everything that you do. It works only on Windows. It won't work on any other operating system. And in Windows, it will copy and mimic all the actions that you're doing in Windows. You're clicking on an Excel sheet, you're copying a cell, you're pasting it inside, like you're logging into SAP, you're pasting that value there, and you're pressing a button, and then it needs to do for every row in that Excel sheet. It will do that extremely well. AI is decision science. AI is where you're actually making a decision on a transaction. That is in the part where you're actually not repeating a step. You're actually deciding whether this is a good transaction or bad transaction, or you're predicting whether this transaction is this loan portfolio is going to pay on time or not. You're making decisions. So they are completely different. AI is what you will use when you are trying to automate high-level tasks. RPA is what you will use when you are using for low-level tasks. Transaction processing, the only thing is, if you have a lot of decisions in your transaction processing, then you can't use RPA. RPA works well when you don't have decisions. When you're just simply repeating, RPA works extremely well. But when you're deciding, meaning, see, you can still do some amount of decisions with rules. If you have only 3 different variations, RPA might still be okay. You could still write rules and say, if it's this, do this, if it's this, do this, if it's this, do this. But once it crosses that level of complexity, meaning you are going to OCR, so which means the type of invoices you're going to get are going to be some 150 different vendors are going to give you 150 invoices. You can't solve that with RPA.
What will be the cost involved in this introduction of AI or product compared to the size of say patent portfolio? Or is there any kind of a cost versus turnover relation with any kind of?
No, there is not much correlation to turnover because see, AI systems are like a lot like telecom type business, meaning the investment or the capital investment or the investment in building that system is already done. You are mostly paying for using it, utilization. So you are not really paying for building it for you. Unlike an RPA type project where a consultant time is very large, in AI type solutions, the consultant time in adopting it is not very large. Consultant time is only to plug your data to that system. Other than that, you are not really spending consultant time on building it. Unless you are building a separate AI system for a very separate problem entirely for yourself, in which case the costing is comparable. But if you are going to use a generalized AI system, the pricing should not be a problem.
What will be the approximate?
See, it's hard to say broadly. So, for example, for our audit system, right, we have an AI audit system in which if you upload a financial statement, it will do an analysis and an audit of trial balance and journal entries and give you back a dashboard. That's like a $500 system. So for an audit, that's what it will cost you. It's because you're not really building that system bespoke. So the amount of time and effort you're going to spend on it is going to be very minimal from a project perspective. But if you say, no, I have a very specific oil and gas industry problem for which I want to build a solution because my firm's a specialist in it, then you're talking about a 10 to 20 lakh project because you have to build something very specifically for yourself. I'm not able to follow you.
He is asking if there is any off-the-shelf AI tool where they can like start using for assessing the risk, start using from day one, anything online.
Yeah, without concentration or focusing on the, building a big algorithm, just to understand the functionality of it, is there any combinations available?
See, if you use to generally get a sense of how these systems work, there are like I said, a lot of the tools that we use already have some AI. Like Google Translate is an AI example so if you put a contract, you paste a contract into it and see how it translates, you will know to a very reasonable extent what is the kind of language translation accuracy you are expecting. Those kind of things, there are tools available. But if you are going to take a very specific use case like audit or accounting or domain specific, generally off-the-shelf tools are not all that easily available. You typically will need to use on a paper use or this thing. You will not be able to get a very generalized tool to do that. But if you want to try something like a BI or try some simple OCR and see whether it is reading it and accuracy, there are multiple tools available online where you can actually test out OCR accuracy, meaning you can upload an invoice as an image and see whether it can read it. You can test it, but a lot of the software, there is some work that needs to be built on top of it before it becomes usable. Even a translation system, what you are seeing is actually an end output system. In the back end, there's a lot of work that's gone on to be able to translate English to Tamil. Thank you.